Hello, in this video we are going to do a utility maximization problem that involves a corner solution. Here is the consumer's utility function. It's a function of units of good X and units of good Y. The consumer has a budget constraint. The consumer has $10 to spend on good X and good Y. The price of good X is $1 each, and the price of good Y is $5 each. The marginal utility of good X, take the partial derivative of the utility function with respect to good X. The partial derivative of 30x is 30, and then the partial derivative of minus 0.5x squared is just minus x. And these other two terms just fall out. They're treated as constants, and the derivative of a constant is 0. The marginal utility of good Y, going to take a partial derivative of the utility function, but this time with respect to good Y. So the partial derivative of 40y is 40, and the partial derivative of minus 2.5y squared is simply minus 5y. We set up our utility maximizing condition. Marginal utility of good X divided by the price of good X needs to equal the marginal utility of good Y divided by the price of good Y. So we're going to make our substitutions into this formula. We know that the price of good X is 1 and the price of good Y is 5, and we just found the respective marginal utilities. So making those substitutions, now 30 minus x divided by 1 is just 30 minus x, and then we're going to take 40 and divide it by 5 to get 8, and then we're going to take minus 5y divided by 5 just to get minus y. So we get this, and now subtracting 8 from both sides, and we're going to add x to both sides and add y to both sides, and we get this expression that x equals 22 plus y. We're now going to take this expression and plug it into the budget constraint. Here's our budget constraint where we have x. We're going to replace it with 22 plus y. And now solving for y, y plus 5y is 6y, and then subtracting 22 from both sides. 10 minus 22 is minus 12, and we have a problem. The consumer, we're told, should buy minus 2 units of good Y. Well, that's not possible. Anyways, with y equal to minus 2, if we plug that into this equation right here, we see that x equals 20. Let's take a look at this solution that we just found graphically. This is not a corner solution, but we have this red line, which is the budget constraint, and that's the equation of the budget constraint, y equals 2 minus 0.2x. And then this blue line is the consumer's indifference curve. And at y equals minus 2 and x equals 20, the consumer's getting a utility of 310. So I'm graphing this expression here. Here's our utility function with u set to 310 to get our indifference curve. And the tangency is right here. So this is what we just found. This is y is negative 2 here, and x is 20. Well, again, this is not possible. So the consumer cannot buy negative units of good Y. The best the consumer can do is not buy any units of good Y, set Y equal to 0. Another problem here is the consumer cannot afford 20 units of good X priced at $1 each. The consumer only has $10 to spend. So the corner solution here is we're going to set good Y equal to 0. Here's our budget constraint. We're going to set Y equal to 0 in the budget constraint. And so the best the consumer can do is buy 10 units of good X and 0 units of good Y. And going back to our graph, the indifference curve here would touch right here at X equals 10 and Y equals 0. So there'd be an indifference curve that would be touching right at this point right here, the corner solution. Okay, I'll stop here.